Yeah, I'm Jim. What could I tell you about myself, just to make it a bit personal? I'm an old millennial, um, which means that I've kind of ridden the whole sort of roller coaster of the commercial internet, really, through all its highs and lows. And I've been privileged for the last 10 years to work for Thoughtworks and just seen a real range of clients, from sort of high risk, super compliance, loads of budget, to sort of high risk, no compliance, no budget, and everything in between, really. And today I want to talk to you about the art of secure software, zero trust delivery pipelines. Okay, cool. So, like, why protect the... Oh, yeah, okay, thanks. Why protect the pipeline? Well, the answer is it's a pretty good, delivery pipeline's a pretty good pinch point to apply security. And that's because all of your changes are going through your delivery pipeline, or your software changes. It also aligns with a kind of DevOps, DevSecOps, shift right, shift left, whatever you want to call it, sort of culture, which is really good. New automation tools and the rest of it. Security often gets a bit left in the dark ages, so it's sort of modern and progressive. And finally, actually, pipelines can be a significant threat point. So let's imagine that your pipeline gets infected with some malware. That means that your production environment is at risk. So a pipeline will actually amplify risks if it does get compromised. So yeah, pipelines are a good place to think about security. Yeah, okay, and so what is zero trust, the other part of the title of the talk? Well, I don't know if anyone's like me, but I get a huge amount of emails, spam emails, in my inbox every day, actually, including at the weekend. And a lot of them are telling me that I can buy some zero trust box from a company like Palo Alto or F5, and I'll just install it, and all of a sudden I'll be zero trust. Well, I'm here to tell you that zero trust is not a product, and it's kind of ironic, actually, because it's never been a product. It was defined back in 2004, which is 20 years ago, as being a security approach that is about going beyond just having a firewall. Back in 2004, there was a group called the Jericho Forum that were coming across new types of vulnerabilities, things like the SQL Slammer, where companies were just getting owned in new ways. And it was a group of people who came together and said, look, do you know what? Security is about more than having a firewall. And in 2009, Forrester wrote a report called Build Security into Your Network Architecture, which was the first use of the term zero trust. And so zero trust has always been an architectural approach. It's been redefined and redefined as we've moved into the cloud era, as security's become much more focused not just on the network, but also on the application stacks higher up, just become a bit more pervasive. I would say if you're interested in zero trust, the paper to read is the 2020 NIST paper, Zero Trust Architecture. It's a little bit dry, but it doesn't go into all the details of what networks were like in 2004, which I think a lot of us would prefer to leave in the past, really. Yeah, it's a little bit dry. There's some good maturity models in it. So I have summarized zero trust using a highly engaging zero trust octopus, as you can see. So we're going to keep on coming back to this throughout the talk, so don't worry about sort of soaking it all in one go. But the 4 principles that we're going to highlight for zero trust are least privilege, verify trust, be breach ready, and be asset aware. And just to give you a notion of this, so with least privilege, we want to move away from being open. So we want to make sure that when we've got systems that they're kind of, the roles are locked down, so people can only do, so actually controlling what people can do. And we want to move to a situation where that's more granular, so we're being more specific to particular contexts. In terms of breach ready, instead of just being unprepared and assuming we're never going to get owned, we're going to assume that we will be, and we're going to be alert to it. And we're going to try and be resilient as well. In terms of verifying trust, rather than just assuming trust, just assuming everything is good in the world, We're going to be explicit and check stuff and make sure it's trustworthy, that it's not bad. And we're going to try and do that in a continuous way. And in terms of being asset aware, rather than just being unaware and just saying, okay, well, our system's just a load of code and infrastructure and technology, we're going to be risk-based, and we're going to think about what are the impacts if stuff goes wrong. And we're going to try and be adaptive. We're going to try and adapt as the environment changes, as new threats come along, as China invents a quantum computer or whatever less exciting threats you're interested in worrying about. Cool. Okay, so let's start from being asset aware, actually, because it's always my favorite. Let's be risk-based. And let's take a risk-based look at a continuous delivery pipeline. So the question is, classic security question, what's the threat model? What's the threat model of a typical software delivery pipeline? And we're going to get into that with two questions. The first one is, well, what is the attack surface of a pipeline? What are the ways, what's the data, what's the stuff that goes into the pipeline that potentially could break it or could potentially own it or could potentially cause some kind of impact? And the second question is, like, what's the blast radius? Like, if something bad does happen, then, like, where's it going to happen, essentially? And this is kind of a metaphor that comes from network architecture. Okay, so here's our software delivery pipeline. And the attack surface we're going to talk about today is the network. Obviously, your CI/CD server is going to be on some kind of network, so people can get into it. Code, so people are going to be committing some kind of code to the pipeline. Seems straightforward. Dependencies, so you're not going to build your system yourself from scratch in assembler. You're going to be pulling in some sort of dependencies, whatever they are, in your particular world. And finally, developers. Like, all of this is being mediated by humans, like, at least for now, right? So there's some people who are connecting to the system as well. So that's our attack surface. What about the blast radius? Well, often we've got secrets, so passwords, that kind of thing, connecting to cloud APIs. Often we're using some kind of platform, whether it's AWS, Azure, or your own Kubernetes, whatever it might be. And then you've typically got a set of environments like dev, QA, test, pre-prod, hopefully sort of familiar, sort of standard sort of setup. So this is your blast radius, really. Because these things contain your production apps that make your employer money, or are providing a critical public service, or contain valuable data of people that can have an impact. So this is the blast radius. This is being risk-based, and this is thinking. So yeah, this is the threat model that we're going to use. Cool. Okay, so let's start with the network, which is really where Zero Trust kind of came from. Now, what's the threat? So typically, your CI/CD platform, portal, your Jenkins or your GitHub or whatever, is going to be connected to the internet. And the problem with the internet is that everyone else on the planet is also connected to it. And a lot of those people are bad, and maybe they want to do some bad stuff to you. So that's fundamentally the problem of the network. It could be an opportunist attack. It could just be somebody running scripts against whatever, and you happen to be in the way. It could be a targeted attack. Someone could say, well, actually, I've got a load of resource, and I want to go pull the lid off that CI/CD server so I can blah, 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 and then steal all the emails from the White House. Not that would ever happen. But yeah, I mean, there's quite an interesting case called the SolarWinds breach, where exactly that happened. So this is why we need to worry about the network. And in terms of the Zero Trust Octopus, we're going to think really about least privilege, about going from open. So in general, I would think about how can you go from more open to more controlled, and even then being more granular in terms of what access you give. And also in terms of verifying trust, rather than assuming trust, just being more explicit and more continuous in terms of providing your CI/CD service to its users. How I'll put it. Cool. Right, it depends, right? So it depends on what your stack is. If you're building on infrastructure as a service, then there's a whole bunch of things that you need to think about. And I would say know your obligations. There's what AWS called the shared responsibility model, which is that if you're running on infrastructure as a service, whether that's EC2 or Kubernetes or something like that, the layers above a certain level, you are responsible for. So if you need to configure TLS certificates, configure them. If you need to keep the system patched, then patch. If you need to lock it down so only developers that you know are your developers and not anybody in the whole world can connect to it, then you need to lock it down. So I suppose what I'm saying here is if you are going to build your CI/CD stack on infrastructure as a service, and there can be really good reasons to do that, good business reasons, then just know your obligations. And if you haven't got really good reasons, then I would say just consider SaaS, right? It's probably cheaper just to pay GitHub or Azure or AWS to kind of do it for you. Okay, and so if you're going to use a software as a service model, just giving some examples, GitHub's very popular. Then, like a load of stuff's done for you, so that's good. It's protected against the internet. But be careful about how SaaS services join together. So one point that's often a weak point is where you've got something like, let's say, an Azure pipeline, which is then deploying into AWS, or a GitHub pipeline that's then deploying into AWS. And you've got to have some way of the SaaS CI/CD thing assuming trust into the AWS environment. So, and someone just creates a AWS secret that can do absolutely everything and is God. That is an accident waiting to happen. So my advice on building with software as a service is always be careful in terms of verifying that trust, how you are, being more granular in allowing permissions between one cloud ecosystem and the next. And in terms of keeping it simple, consider just having one, right? I mean, maybe GitHub is better than AWS code deploy for X, Y, Z aesthetic reasons, but from a security perspective, maybe it's better just to have one platform because it's going to make you much more secure. Cool, and in terms of your users, simple stuff really, but probably in 2023, developers should be using MFA. Ideally using the QR codes and the generator apps and typing the numbers in. It's just best practice really, particularly if you're connected to the internet. It's so easy to have weak credentials or a password that's hanging around. And even if you're not going to do it, then someone on the team, that contractor that you've just got in for a month. Credential strength, MFA, is something really to think about. Particularly because all the code that gets chucked in could then end up on production, right? So it's like a back door into your production environment. Yeah, and think about, it's not just technical in terms of your users of the system. It's not just technical. Also think if people are leaving your business, or if they're moving to a different department, or if they're moving from being the platform team to just working on a less impact sort of product, then you've got to have a process. It can't just be talk to Sandra. She's got permission to give you all the permissions you need. Just clone mine. That's an accident waiting to happen. Particularly if you're going to be subject to targeted attack. Maybe you're not, right? But if you are, then that's an accident waiting to happen. Yeah, dull stuff really, but coming back to targeted attack, if you think, if your system, and some of them will be, right, if your system is subject to targeted attack, highly resourced, capable attackers who are going after you, then they are going to look up on LinkedIn and they're going to see that you're principal software developer for XYZ, and they're going to, or the contractor that you've taken on for 6 months, who's using their own laptop, and they're going to target the device. So forget about the system, right? They're going to target the endpoint device. So this can seem really dull to developers because we don't want to be slowed down by some locked down laptop. But it is a real point of threat. Particularly if you've got a platform team that can make significant changes to production, the endpoint devices are going to be targeted by drive-by downloads. Someone will send through a link. They'll take control of the laptop, and then they'll be able to get into production that way. It's a bit enterprise IT, but But definitely consider endpoints in terms of your threat model. It's a big part of Zero Trust, is making sure you've got lockdown devices with anti-malware and advanced protection, particularly for the people who can make the deepest kind of changes. It's a real threat point. Okay, so that's the network. What am I doing for time? Yeah, attack surface dependencies. So why are dependencies an attack surface? Well, the typical one is sort of vulnerable third-party libraries. So you've got the classic, I've got a CVE in log4j, or what was it that Andrew referred to? I've got a CVE in struts. I mean, there's got to be a CVE in struts, right? So that's one thing, is that the dependencies will have some kind of vulnerability that you're then deploying to production, so you need to upgrade it. The second one is kind of malicious packages or type squatting. So this is where somebody creates a package that's got almost the same name as the package you need to use, but is actually just a virus. Like, it's just a virus, and it's just intended to escalate privilege into your kind of environment. So these are the kind of attack vectors that we need to think about in terms of dependencies and CI/CD. Yeah, and the approach that we can kind of adopt is, verifying trust. So rather than assuming that all dependencies are good, we need to be explicit about what are the properties of a secure or a valid package. And ideally, we need to do that continuously, which we're in a good situation to do, right? Because it's a CI/CD server, and it works continuously, so we've got a mechanism there. I think the other thing that I'd like to highlight in regards to dependency is that, like, everything you do, you could still get a bad dependency. So you need to be ready for if you do have a bad dependency. And we'll talk briefly about ways to approach that. Yeah, so it's 2023. The automation is actually pretty good around dependency checking. I guess probably a lot of teams do use dependency checkers. I'm not going to give a specific recommendation. I would just say use the most appropriate for your stack. OWASP dependency check, Sneak's good, Dependabot's good. It's just a no-brainer usually. There's some more modern approaches called software bill of materials, which are really interesting and cool. I'd definitely say try those out. They're not as well, they're one of these things, they're a bit like Facebook back in the day. They have to be adopted by everyone to be fully effective. There's like a network effect to SBOMs. And they're not quite there yet, but definitely have a look. Yeah, I mean, the general message is automate dependency checking. But there's a big pitfall with anything automated in the pipeline, which is a thing called red fatigue, which is that, let's say that you've got a dependency checker in your pipeline, and you've got, I don't know, let's say you've got 500 dependencies, which is not unrealistic, right? Every day there's some little minor issue in the dependency that pops up, and every day it's distracting because we've all got other stuff to do other than messing around with dependencies. So what happens over time is the dependency check gets commented out and it's just informational, or it's like, oh, well, Steve will have a look at it once a month, and then a couple of months goes by and it just gets completely ignored. And this is really common. This red fatigue is really, really common. And then what happens is a significant dependency gets through. So one that wasn't just minor comes through, and you've got an all-hands-on-deck scenario to patch, or even worse, you get breached. So my advice, it's not an easy problem, but my advice would be just consider continuously applying the latest versions. So every time you do a build, just pull in the absolute latest version, because the latest version is always going to have all of the security patches, right? Just because it's the latest. Historically, you can ask a question later. Historically, we haven't done this. It could be that your legacy environment, this is just not possible, right? Completely accept that. But often you can, particularly with greenfield environments, and particularly if you've got enough rigor in your tests. You should be able to do it. And what you're doing is you're taking a little bit of a gamble on availability, but you're ensuring that confidentiality and availability are maximized. So I would recommend this. I've been recommending this to projects for 10 years, and I can only think of one example where it didn't work. Yeah, and so what if you can't? Or even if you do apply continuously, there still might be a dependency that causes a problem. I would say it's useful to threat model. dependencies, get together as a team and try and work out which dependency is it that could cause that log4j, it's Christmas Day and everyone's panicking, patching production scenario. Work out what it is and just conduct a tabletop exercise, conduct a simulation and work out what you'd do. Because I can tell you now, you'd rather do that than wait till Christmas Day and your phone's ringing and it's time to patch a TLS vulnerability on prod. Cool. Okay, so that's dependencies. So let's talk about code. The code is an attack surface. I mean, you could have a whole conference of talks about all the different vulnerabilities that can come in via code. Authorization bypasses, hard-coded secrets, input validation, business logic flaws, authentication flaws. There's, I think, literally an infinite number of possibilities of vulnerabilities that could be introduced in any kind of line of code that's checked in. And so using the zero trust model, what I'm going to talk about briefly is taking a verified trust approach, so moving away from just assuming that every change is good to being explicit about what a good change is and doing that continuously. And also being asset aware, which I think is the key with securing code that's getting checked in. So being aware of, on a risk basis, what are the bits of code that are most risky? What are the bits of code that could actually cause a security problem? And actually, is that CSS change actually a risk at all? Maybe it's not, which comes into being adaptive. Yeah, again, automation is a superpower. The tooling is brilliant nowadays. If you look at stuff like CodeQL, SemGrep, and compare it to what we had like 4 years ago, before the pandemic even, it's like, the tools are incredible. And, you talk about static analysis for security, but some of these tools are like programming languages in their own right. Yeah, so definitely use them. You can still have the red fatigue issue with these tools. So if you just switch it on, you can just get issues popping up. But I would say, like, the inner geek in me wants to speak to the inner geek in you and say, take ownership of the power of these tools and the kind of things that they can detect, right? Tailor the rules to your code base. Are you accepting like loads of untrusted like input from users from the internet? Right? Well, okay, so that's probably something to get really interested about. Let's do some threat modeling. Let's write some SemGrep rules to actually be really robust about putting types around what those things can be and invariants, so we're not going to accept the worst kind of stuff coming in. So really get into your niche. Yeah, that would be my advice. Don't just see this tooling as stuff that you can install and forget, but get into what is it about my code base that I can use automation, I can use massively powerful tools like SemGrep, CodeQL to detect and leave it in your pipeline. This is like unit testing for security. It's brilliant, brilliant stuff. But it's not just for the tool to understand your system, right? Your team needs to build up a mental model of what it is about your code base that could break production and cost £1 million a minute or whatever that number is in your environment. So things like pair programming, like maybe one developer's got a better mental model than the other, so pair programming is a good way of teaching. Okay, well, you need to watch out for that because, I didn't even think about that. What if somebody doesn't upload a PDF, but they upload a malware? I didn't think about that. More junior developers are going to be in that position. Curate a security review guideline, right? You read like any security code review guideline, it's 10,000, pages. But just have like, what are your top 5 things that everyone on the team needs to think about? It's probably not SQL injection unless you've got a very specific tech stack. So tailor your own security code review guideline. That would be my recommendation. And like integrate it with how you check in. Like maybe you just do, everyone just pushes to main and you do paired programming. Then build it into that. Or maybe you use PRs and everything is checked. Well, okay, so that's a really good way to refer to your security review guideline. So yeah, use the human intelligence on this and deeply understand the threat model of your environment. And part of that's training. It's, you don't just get born understanding the security of code. Like, code's complex, and then the security of code is like second order complex on top of that. So invest in training, invest in security champions, threat modeling, proportionate to the risk, essentially. Yeah, and I don't know, this is probably a little bit maybe obvious, but so many times I see it not done. Like, if you've got a security critical feature, say you've got a system for providing information to doctors, and there's another role which is like an administrator, and those authorization rules are actually really important for GDPR. And if you don't enforce them, then you're going to get sued, and you could go out of business. Well, test them, right? So this is taking your threat model and it's bringing it back into how you test your system, and it's treating the security of code as requirements, first order requirements that you're building into the product. And don't be afraid to stop the pipeline if they fail, and say, okay, well, if we deployed this production, we wouldn't be compliant. We would be running too much risk. So verifying trust in code is to a large extent about having a mental model within the team. Okay, I'll just have a quick... Right, developers. So probably there's a lot of developers in this room. So developers are going to be interacting with your CI/CD system. And I think there's always a tendency, or I've observed a tendency, to want to think, okay, well, I know everyone on my team, like, we all hang out, we all have a good time, nobody's bad, nobody's working for whoever it might be to subvert the system. But often, security vulnerabilities can just be caused by accidents. Like, maybe somebody does something by mistake or without understanding the consequences of it. Also, sometimes you do have malicious activity, right? I mean, I was referring back to the, endpoints getting owned, but, you could have somebody connected to an endpoint, like a laptop, and then using someone else's identity to commit changes in maliciously, right? So you have to be realistic about the threat, and you have to accept that malicious activity from the development team, from the DevOps team, from the platform team could happen, particularly in certain sort of use cases. And finally, developers can be targets for social engineering. This does happen where, somebody is targeted based on, boasts on LinkedIn, and then they're bribed, or I did a particular role, actually, that was quite, was subject to targeted threat, and I just got loads of WhatsApp messages from, Chinese women. That really happened, and I was like, well, this is puzzling, right? This is real, this social engineering, you just block. But yeah, I mean, it is worth bearing in mind that people do get targeted for social engineering. Yeah, and the approach really is to be least privilege, move away from being open to being granular, and to be breach ready. Assume actually that it will happen, and work on that kind of basis. Okay, so I think the best control is just really, really boring, and it's really frustrating for developers a lot of the time. But using least privilege authorization, so just like breaking down, who's in which team, and only giving people the permissions that they need to do their job. So if somebody is a new starter and all they're doing is updating, some CSS on the web page, then don't give them write permission to the network rules in the Terraform for the core Kubernetes cluster. That's kind of the thinking that you want to apply, is like, rather than saying, okay, everything has to be locked down to the nth degree, say what are the highest risk bits of the code base, and then let's make sure only the people who need to be able to update that code for their job are able to update it. Network rules is a key example of that. Equally, administrators on the CI/CD platform, like if everybody can create an admin on the CI/CD platform, then everyone can deploy to production and everyone can bypass every single control. So it's kind of dull, but it's really, really important to lock down the least privilege authorization within of your CI/CD stack, particularly if you've got a big development team. If you've got 100 developers or 200 developers using a system, then you need to be giving it some of this kind of thought. And you need to think about it as you grow, because so often you set up a project and it's like 3 developers and everyone's God mode. And then 3 years has gone by and you've got 500 developers and you've got a homegrown deployment system and everyone's got permission to do everything. So this, it sounds so dull, but it's just really important to do fine-grained authorization. Last time I gave this talk, I actually got feedback that this bit was too boring, so I've made it longer, because it is very boring. But yeah, slightly more interestingly is to like assume breach. So assume that people will do a bad thing, right? And all of a sudden, monitoring and logging and what is in old-fashioned terms called audit logging is really, really powerful. It has a sort of panopticon effect that if you know that everything you do in the system is going to be logged and potentially looked at, it even makes accidents less likely, because you're aware of the fact that anything you do is essentially being monitored, right? So keep a log of actions, deploys, changes, make it hard to delete the log, so that you've got high integrity in your monitoring. Alert on like risky, unexpected events. Like if you're completely based in one time zone and someone does a full prod deploy at 3 in the morning, then okay, maybe you don't want to stop it. That could be an emergency change, but maybe it'd be worth someone reviewing that and saying, okay, that's an anomaly. We need to investigate. And in this space, sort of consider threat hunting. So, like, think about what are behaviors that would be unusual or anomalous. Like, let's go and look at all of the changes to the core Kubernetes network perimeter rules that connect to the internet. Let's go through them one by one and make sure that we can account for all of them, right? Oh, that's funny. There's a connection to a server in China there. So consider threat hunting. So rather than looking at everything, think about the worst thing that could happen and work backwards to try and detect things that are wrong. And be aware that doing some of this stuff can have a deterrent effect as well. It can build a culture of accountability when you know that everybody is watching everyone else, if you see what I mean. And to come back to the sort of asset aware thing, okay, you've got some CSS or you've got like a front-end app that is pretty low risk. You don't do it on that. You do it on your highest risk bits of the system where real bad things can happen. And so you focus it. You focus the control where you need it. Okay, yeah, part of being ready for a breach is instant planning and response. Have some kind of plan. What happens if, and make sure everyone's aware of it, and follow it even for near misses, to make sure the process works. Because when the worst thing does happen, you want it to be on rails. You don't want to be, you don't want to have your hair on fire. You don't want to have to be calling external instant response support just to help you get the basics right. Yeah, and do a root cause analysis. Like even for a near miss, do a root cause analysis and say, how can we continuously improve the security of our pipeline? How can we continuously improve the security of our system? Cool. Okay, so we've done all these, network, code, dependencies, developers. At less length, I'm just going to quickly talk about some of the blast radius and just some little things specifically there. There's something really specific about secrets, right? I mean, I suppose there's just... I always got this kind of measure, like, could I explain it to my gran in a couple of sentences who's got nothing to do with IT? And, like, I couldn't explain the secrets thing to her, right? But secrets are passwords to systems that might be embedded in your system. And they just seem to be this magical, accidental spot where all of a sudden you're mining Bitcoin, or all of a sudden your entire stack has been owned because you've pushed a secret to GitHub and someone's pulled it down. So secrets are just this thing that can hurt you. And so using some kind of automation around secrets, again, it's just being asset aware. It's being aware that there's something special about secrets that'll hurt you if you just check them into your production, into your plain text code. Something about least privilege, it's saying, okay, you can only update it under these specific situations. But yeah, just use a tool, centralize it, use a tool. Maybe it's AWS Secrets Manager, maybe it's HashiCorp Vault, maybe it's Azure. It's whatever's specific to your use case. But Secrets Manager is something that is going to be a must in any environment, really. Yeah, and then I think finally, possibly finally, think about your environments. So dev, QA, test, whatever it is, however you've got your environment set up. Again, apply that least privilege, asset-aware thought process where we're saying, okay, so production, that's where the production database is. Oh yeah, 2 months ago, we copied the whole production database, including all the personal information, into the performance test environment. Okay, so maybe we need to think about the performance test environment. I mean, so it's not difficult stuff, right? It's just thinking through, okay, dev environment hasn't actually got any sensitive data in it. Okay, maybe production does, maybe pre-prod does. So this is all I'm getting at with asset aware, is think about which bits of your system have got the highest blast radius, the highest impact, and apply the controls there. And least privilege is a perfect control, right? So, yeah, does everyone really need write access to everything? Do developers really need to be able to go in and make changes on production at any point of day? Admittedly, a few years ago, but I've had developers argue the case on this. It's just like, oh, we need access to everything. We need to be able to do X, Y, Z. In certain situations, it's a really good risk mitigator. Maybe you say just have read access. Do you know what I mean? Okay, that'll allow you to do the bug fixing. Maybe just have 2 people on the team who've got write access, or maybe manage it with a ticket, or maybe have another team do it. But when you get into your most sensitive data in the most sensitive parts of the system, there's probably some benefit to having some lockdown. There's probably some benefit to having some least privilege authorization around the most sensitive assets. Likewise on dev, if there's no sensitive data, then, let everyone have at it, if you see what I mean. I mean, people, the impact isn't the same. That's what I'm getting at. So to operate this sort of model, network isolation or some kind of isolation, whatever your infrastructure stack is, some kind of isolation between the environments is important. And that can extend to the control plane, not just the sort of data plane, if that makes sense. So if anyone's got permission to update the Terraform that changes the production Kubernetes instance, that's kind of just as bad as everyone having a password to log into the admin console, because they can add an account or they can change it. So as you structure your environments, make sure that you're applying least privilege, essentially. So dull when you put it that way. Yeah, and this is perhaps a little bit AWS specific, but there are definitely patterns around how you harden your root account structure in order to make sure that production and environments that contain production data is locked down. And I think the key point that I would make here is your CI/CD runners, so the actual infrastructure that runs your production CI/CD should be run as production. It shouldn't be part of the development environment that anyone could change, because it will allow escalation of privilege. So as you're setting stuff up, it's difficult because often you're setting up a dev environment and the CI/CD system at the same time. But try and make CI/CD production from the start and lock down like production from the start, because it needs to be able to deploy into production. Hopefully that makes sense. Yeah, I think I made this point. Yeah, if you have an instant on an environment with prod data, then that's an instant. Cool. Okay, so in relation to environments, again, verifying trust. Don't just assume trust. Make it explicit. Make it continuous, and assume that you can have a breach. And yeah, I think this is a really interesting approach, actually. So one way that you can do that to bring all of this together is consider having your pre-prod environment as a kind of threat hunting sandbox. So what do I mean by that, right? Let me sort of paint you a picture. So you could almost think of this like a fitness function, right? That you've got like an architectural fitness function that any change that goes to production is not going to contain any kind of malware. And think about it laterally, right? So one thing that we did with a client is we made it so that when we deployed to pre-prod, we used a service called AWS Guard Duty to pick up any changes. So we had the dependency checkers. So we had all the code review stuff. But we assumed, what if somebody got some malware into that package anyway? What if they got past all the defense in depth? What's the first thing that that malware is going to do? It's going to call back to some command and control server on the internet that's owned by somebody who's trying to attack you in order to get its instructions. So we had call it a fitness function that when the system got deployed, when the end tests were running, if it detected any outbound traffic trying to get out of the network on pre-prod, it stopped the line. That's a simple example, right? But it's connecting the dots on how you can build fitness functions into your pipeline to ensure that you're protected against essentially high threat actors. Cool. Okay, so doing for time. I'm doing all right. In summary, yeah, secure the pipeline. Zero trust is a proven security architecture approach. Yeah, turn a security liability, which is your CI/CD pipeline, into a security asset. Yeah, think about least privilege. You go from open to controlled. Try and be granular. Be breach ready. You don't want to be unprepared. You want to be alert, and if possible, resilient. So if something does happen, you're able to quickly recover and minimize the impact. Verify trust. So don't assume trust. Be explicit, say what good looks like in terms of trust, and make that continuous. So every time the pipeline runs, you're checking it. It's not something that happens once a month or by an exception. And finally, be asset aware. I mean, a lot of the problem with security is that you can sort of, if you dial it up to 13, all you'll do is security, and eventually someone will say, look, we need to deliver some features. Being asset aware doesn't mean having all the controls on every single bit of your system. It means being risk-based to understand which bits of your system are most likely to cause a problem, and then applying all of the control in that particular context. And then if your system changes, have a mechanism to be able to continuously redeploy your controls. And that's the essence of Zero Trust, really, and Zero Trust Octopus. Cool. Thank you for coming, and thank you for listening.